All right, hello everyone. Today we're going to talk to you about our game War Cubed. I'm Justin.
I'm Zach.
I'm Victor. I'm Mitch.
All right, so let's get started. So a brief overview of our team and kind of what we've been all doing. So Zach's been spending a lot of time getting our main game field set up and working with all the cubes and the camera controls and things like that. I've worked with user interface a little bit with the menu system and the cube rotations. Victor's done a lot with the gameplay firming, a lot of other the UI elements, and Mitch has been great with working on our AI systems in the game. So just to give you a quick overview of our game and remind you what we're doing. So our game is called War Cubed, and it's basically the game of Risk played on a Rubik's Cube. So you have all of the classic things of Risk of reinforcing spaces, attacking and defending, and things like that with dice rolls. But the unique aspect about War Cubed is that we have rotations in place. So at the end of your turn, you gain the ability to rotate a face of the cube. And what this basically allows you to do is really screw up the playfield. So if the enemy is about to win, you can rotate a face and totally screw them up. Or maybe you could even rotate a face and you would win the game. And the win condition that we have in place for this is capturing an entire face of the cube. So you could have 6 of these captured and then rotate in 3 more of your spaces and win the game. And that just adds a really cool dynamic element to the classic game of Risk. So to walk you through kind of the game setup, this is the first menu that you'll be presented with. Excuse me. You'll walk through setting up a new game. We don't have options or load game in place right now, but you'll go and choose your game mode. Go through basically these options and select against AI, number of players, and then the difficulty. And not all this functionality is implemented, but just to give an overview of what the end goal would be to have different capture modes, being able to play against a real player, and being able to modify the number of opponents and the difficulty of the egg or something that we definitely want to have in. So to get a quick overview of the flow of the game and how the turns work. So when you start your turn, you get reinforcements depending on how many faces that you have captured, and you can go through and reinforce different spaces or claim neutral spaces if there are any neutral spaces. If you have any rotations available, you can enter the rotation phase and rotate any of the tiles. To do a rotate, you basically click on the center of the tile that you want to rotate. A left click is a clockwise rotation, a right click is a counterclockwise rotation. After rotations, you can enter the war phase where you can battle any enemy units that are adjacent to any of the tiles that you own. Through any of these 3 stages, if you end up capturing an entire face of the cube, then you win the game instantly. So that's one of the really cool components that it can look like you're really far away from winning, but with a couple of rotations and a couple of attacks, you might actually win the game. So that's just a quick overview of the flow of the game.
Alright, so I'm going to be talking about some of the designs, again, mostly the user interface. So on the top, you pretty much have the game flowchart icons, which would be the deployment phase, the rotation phase, the attack phase. And the way that it happens is the enlarged icon is the one that you're currently in. And then when you click on the rotation phase, that takes you to that rotation phase. And then that icon becomes enlarged, and the ones that are dimmed out are disabled. So you can't click on those because you want to go one at a time. On the top right-hand corner, or your left-hand corner, you have the face cards, which lets you know how many rotations you have available. One card gives you a 190-degree rotation. So if you wanted to completely turn a face around 180 degrees, you would need 2 cards. And then you have text that basically says which player turn it is. All right, so the attack system. So there's a filtered attack system going on. Pretty much depends on who is attacking, who's defending. So if you're attacking as one attacker, you have only 1 troop, and you're going against 1 defender, then the odds are 50-50. However, if you have 2 attackers, or you're a person with 2 attacks, and you're going against 1 defender, there is a 15% chance increase that you're going to win. So the way it's calculated is that it's off of a difference of troops, and each difference is 15%. All right, so the way that attacking works is that you would go to your attack phase, and then you would be able to have, when you click on the cube, you would have a green selected icon or selected face, and it will show you which of those icons you can attack. These are currently gray, simply because these are territories that you own, and the red would be the opponent naturally, so that's how that would be handled. And then we are brought up to our AI logic. So we kind of have three paradigms for the AI, and there's angry, conservative, and greedy. Angry is basically your very offensive AI, and the idea is that they're always going to try and capture your troops. So you're going to spawn their troops as closely to you as possible, and then try to take and conquer that base. Then you have conservative. Conservative is basically your turtle-based AI, who pretty much just wants to kind of make sure that they stay on one face and securing that one face. And then you have greedy, which, because in the game you're allowed to put troops on, you're allowed to put a troop on already existing or a face that you already own. Greedy would be pretty much spreading out your units as much as possible to kind of occupy as much space as possible, but it's not really well secured. It's kind of very like a risky kind of strategy where you kind of spread out your troops and hope that you win. So that's kind of what goes on there.
So the AI, when you think about it, is rather complicated. You can start off by thinking of it in simple terms. You can create a coordinate system and assign your battle zone in two-dimensional space. And then basically it becomes a flat surface, more or less. Because, as many of you are probably familiar, even two-dimensional or multi-dimensional arrays are really just a long line of indices. So when we need the AI to determine what it's going to do, it needs to be fairly structured in order to handle the complicated bit of strategizing and handling the rotations and determining what it wants to achieve, which faces its objective, etc., etc. So we make this more simply by tying the AI into the state machine that controls the turn system. So for each state of the turn, the placement phase, the rotation phase, we tie the AI into that so that it knows what it wants to be doing at that moment. In games of Risk, a player has an objective. Frequently you give a little card and says, take this phase, take this, or rather take this country. And we don't have that luxury because it's a six-sided figure and all sides are equal. So what we want to do is constantly update the AI. Have it always, its objective always changing, where instead of reaching out for a goal, it's searching all the possible goals in the future and moving towards the closest one. So if a tile is available nearby, depending on the type of AI, angry might take it, conservative might not, but all with the end objective of moving closer to capturing a face. So it's somewhat easy to think about when you're simply thinking of moving tiles and attacking. However, when you think of rotation, it becomes extremely complicated. You have to, the AI has to be able to keep track of not only its own tiles and where it wants to move them, but the effect that rotation is going to have on the integrity of the forces it has. Because with every rotation, there is always a balance, and that you are bringing other tiles closer to you. So to keep track of that, the logic tiles are control very quickly. So initially we looked into using some of the things we learned in class and found that trying to implement them as the standard vanilla way didn't quite work for us. We had to go in and pretty much write up custom behavior for almost every situation. And so that leads to a lot of functions that we ended up creating a library for. And these will be modified by the different, genomes of AI, and altered in a certain way to produce different behavior. So for instance, Angry really likes to place tiles on corners of faces that you own. They tend to be far enough away from your troops that it's a less risky behavior, but it tends to be very difficult for you. So basically, as you can see, the AI is tied into the state machine, and it begins performing behavior fitting for that AI's type. So for Angry, it searches out for neighboring tiles that belong to opponents, and if the calculated probability, which it does using a series of simulated dice rolls, turns out to be good enough odds for it to make an attack, it'll do so. And it'll do so continuously, constantly updating its objectives based on how many armies it just lost, how many armies the opponents just lost. So in a battle where perhaps maybe you lost, the end outcome is that you were unable to take the tile, the AI might still realize that it opens up a new objective or a new goal, where now because of that weakened tile, it can perform a rotation and make a faster movement towards its goal.
So moving off the attack system, we finally have one final rotate system that we had to create. And this kind of posed its own difficulties because not many people create a rotating game board that's always changing, not from just movements by the player, but the actual movement of each tile in this board. So we kind of had to create our way of allowing the enemies to move away or move into a position, or for you to either move away or move into a victory. So what we kind of had to do was we had to look at our game board, which we had as a two-dimensional array, and we also had to have whether our faces and also each individual block. Because Unity is really, really annoying to use in 3D, we had to first find a way to rotate each block and face so that we could logically then link everything up. So this was kind of the gist of what we did in our rotate system, where we had our rotate function. It took the side, so if you're on side A, it takes and sees if you want to rotate clockwise or counterclockwise, and it takes in our array of faces, which is each 9 faces for that side. So then it does our if check, sees if we're going to do clockwise or counterclockwise, and then it creates a switch stage out of that, saying if side A, we're going to turn on the variables that our update loop is checking to actually do the physical movement. Because if you're doing any physical movement in Unity, no matter what it is, it has to be in your update loop to kind of make it smooth. So we had to find a way to create a state machine that's dealing with its own function, but also passing the parameters back for the update to check. Once it's finished, we turn the update loop off for that section, and then we logically rotate our faces and our actual blocks. So this was just creating a temporary array and then reassigning the positions for each block. So we kind of created our own state machine in this by just seeing what we needed to do for physically moving the board and also logically moving the board. So now we're just going to show you what we have for the game. So as I was saying, this is our menu system that we boot into. We have our new game option, which is currently linked up. So select a new game. We're going to play face capture. We're going to play against AI. And then we'll just say we're going to play against one other AI. And we'll set them to easy because I'm terrible. So this is our game. And as you can see, we have each side is set to a different background. This is making it easier for us as a player to kind of associate which side is which. So we have red nebula, blue, our green, a different green, our asteroid belt, and our starry sky. And then going into that, which is just going to show us the actual attacking and the AI doing its turns.
So, as someone who has no experience in Unity before, understanding how physical objects represented with code work was quite a hassle. So, as you can see, each of these items are a little cube, and they all have our ever-important tile faces on top. So, based on the turn system, at the moment, the first turn, the player does not get to place a tile. So he moves into the rotation, he moves into the attack, and select a tile that he owns, and then attack. And he will now own that tile, and he can end his turn. So during this time, the AI is now attacking, and you can see, there we go, that he preferred to move to this tile. The AI in this case chose to move to a tile on a face he owns, and when he ends his turn, we can pretty much continue to repeat the same thing over again. The implementation of the AI is extensive. It's the actual game use of it that is still has some hiccups, and so while it works pretty well, the AI still needs to be implemented well to make it work. So that's some stuff we still have to work on.
Yeah. So we have our AI system that we're still implementing to actually be playable. We have most of it, but it's just getting the final links to make it show where it's doing the attacks. Some physical things like holding the actual red or its actual color. And then the rotate system is logically implemented, but because I can't rotate a cube 90 degrees on its center right now, I can't visually show it well. So logically we could rotate, but it will mess it up because it just won't show that it's rotating. But other than that, does anyone have any questions? What's up, Bernie?
So, I was really interested in the different AI behaviors and how you made like one conservative, one angry. And I guess this is sort of a novel game. I'm not sure how much you guys have played this kind of game among yourselves. So what was sort of the thought process? Like, how did you go about developing these AIs that follow this strategy if the actual strategy to play the game is still kind of fuzzy, I mean, is it just like what seems right, or?
It was a lot of what seems right.
Yeah.
And a lot of, basically, there are a subset of actions you can perform. And so, based on the calculated simulation probability of whether or not within 2 turns it can attack that tile, a risk-taking AI would go for that. A more conservative AI would not. And so in each of those things, there are several different ways to achieve that goal. For instance, a rotation or attacking 9 tiles in a row to get there. And those different ways of doing so fit with different personalities of the AI as well.
So it's not so much like a specific strategy, but it's more like this AI favors this type of movement, so we're going to prioritize the actions that it takes to get to that sort of movement.
Yes.
Sort of thing. Okay, that makes sense.
Although it also depends on the objective and reach.
Sure.
So if it's close enough or perhaps achievable in a way that it's solved, it might a very conservative AI might perform a very drastic maneuver as long as it believed that it fit within its personality.
Sure. Okay.
Anybody else?
I have a question. Can you talk a little bit about your design process, including any brainstorming or design documents you created, or how you may have changed your game at all due to any playtesting you did early or late in your design process?
If you would like, we can bring up our game design document that we actually
Can you describe a little bit about your process to create that?
Okay, so at first, the idea was we were going to want to implement a bit of animation, so we wanted to actually represent the models on the cube. However, we had to kind of shortcut that simply because the rotate logic became a little bit more of a logical problem than we expected it to. So we kind of had to cut corners on animations, and you can see that also happened with the rotation. We only were able to implement it on the logical end. So it logically rotates, doesn't rotate animation, and we kind of just, we had stretch goals that we wanted to meet, and we did find ourselves not really meeting our stretch goals, so we just kind of had to break down our core design, and we prioritized showing and actually logically having things working rather than having like something visually pleasing to show. And when it comes to the actual UI designs, They're not really fancy, they're fairly minimal, but it still conveys the message. It still shows you like what stage you're in. You can still press the button to move stages, and it just, we're fairly minimal with everything other than the actual logical implementation of the game.
And in terms of on the run design, basically if there was a point and it could be considered in one way or the other, we argued for 45 minutes about it. So I think for a group where very different ideas, it would be something like, should a player get a rotate card at the beginning or the end of the turn? And that would turn into a 45-minute discussion about the merits, well, heated discussion, about the merits of what it did for the game, what it did for the design, whether or not it'd be easy to implement, and also, the whole 9 yards. And I think as far as building a concept, that we did very well because of it.
How do you think that industry game design teams solve an issue like that, where there's just a difference in opinion between teams about something like that? That's a game balancing question, a game mechanics question.
I think it largely has to do with what your audience is. So, for instance, this is a strategy game. Our main audience was to appeal to strategy gamers, which the idea was to just implement it around it being a logical puzzle. If this game were geared towards more of a younger audience, we would probably make the game a little bit more simpler, perhaps even prioritize visuals to make it even more visually intuitive. The matter of fact was that we did expect our players or our audience to actually to want to play the game and have that logical aspect more favored than the visual aspect. So in terms of a project and what we can get done, we wanted to make sure that we appealed to our audience, and we mainly made decisions based off of that.
Great. Well, the answer to my question is playtesting and game balance sessions where you do a lot of this stuff offline. You're not always going to be able to resolve it with a decision without having played it or having anyone else play it. So this is something that I try to emphasize in the class, and hopefully you've learned that your method isn't the most efficient, and next time you might consider getting some outside opinions to help you make those decisions. So we're pretty much out of time. Does anybody have any last questions? All right, let's thank the group, and then